This video goes over how to rearrange equations from lines. So the equation of a line can be written in two different forms. The first form that we know already is slope y-intercept form. And then we're going to introduce a new form in this video called standard form, which can be found by rearranging slope y-intercept form. The only restrictions here are that you can't have any fractions and that the a value has to be greater than 0. So let's do an example where we're going to express each equation in standard form. So kind of like an equation, we're just going to move everything onto the left-hand side and change the signs. So minus 4x on the right moves over, becomes plus 4x. The y hasn't moved anymore, so it stays as positive. And I've got minus 5 equals 0, and I'm all done. The next one, I'm going to do the same thing, except when I move all my terms over, plus y plus 6, I notice that I now have a negative value in front of the x. I can't have that in standard form, so I'm going to multiply everything by minus 1 so that I can change the sign from a negative to a positive. The only effect that multiplying by minus 1 has is just changing the signs. In C, we have a fraction. Fractions are tricky. We want to get rid of them if we can. So I'm going to multiply everything by 3, which is the denominator of my fraction, so that I'm left over with 3y equals 2x plus 9. Now it looks just like really my second example. I'm going to move everything over and change the sign. And then I'm going to multiply everything by minus 1. Giving me my equation in standard form. My final example has two fractions, which means that I need to multiply by the common denominator, which in this case is 12. Then I'm left with 12y minus 9x plus 4. Now I can move the 9x and the 4 over onto the left-hand side to get my equation in standard form. You should also be able to go from standard form into y equals mx plus b. In this situation, really what we're doing is we are solving for y. So we're trying to get y by itself. So the first thing that I'm going to do is move 3x and negative 11 over to the right-hand side of the equal sign. And I'm going to flip the signs. The next thing that I'm going to do to get y by itself is divide everything by 4. On the left-hand side, I'm left with y. On the right-hand side, I've got fractions, but that's okay. I've got minus 3 over 4x plus 11 over 4. Let's try the next one. So just like before, I'm going to move my x and my 7 over, leaves me with minus 3y equals minus 5x minus 7. And then I'm going to divide by the number in front of the y. And then I'm going to simplify. So I still have fractions on the right-hand side. That's okay. But I've got two positive numbers because I divided everything by negative 3. Example C, I'm going to move 3 and minus 4 over. So I'm left with minus y equals minus 3x plus 4. Then I'm going to divide everything by the number that's in front of the y, which in this case is minus 1. That leaves me with 3x minus 4. Example 3 is asking us to state the slope, the y-intercept, and the x-intercept for each of the given equations. So let's do the x-intercept first. So to find the x-intercept, I want to set y equal to 0. So that means I have 5x minus 3 times 0 equals 15. I've just replaced the y in my equation with a 0. That eliminates that term. So what I'm left with is 5x equals 15. Now I can divide both sides by 5, leaving me with x equals 3. And my x-intercept, if I were to plot it on the graph, is 3, 0. Now I can actually do the y-intercept the same way, just by setting x equal to 0. So now I've got 5 times 0 minus 3 times y equals 15. That eliminates the term that had the x in it. Now I've got minus 3y equals 15. Now I can divide both sides by minus 3, which gives me y equals minus 5, and then my y-intercept would be 0, minus 5. Now, I found the y-intercept, I found the x-intercept. Now I need the slope. My equation has to be in the form y equals mx plus b for me to be able to find the slope. So let's rearrange that now. So I'm starting with this. I'm going to move 5x over onto the right-hand side. So I've got minus 5x plus 15. And then I'm going to divide by the number in front of the y, giving me y equals 5 over 3x minus 5. Note that my y-intercept is the same that I found by setting x equal to 0. And now I can identify my slope as the number in front of the x. Let's do that for two other examples. So for my x-intercept, I'm going to set y equal to 0. 2x plus 4 times 0 minus 8 equals 0. Now I've got 2x minus 8 equals 0. Solving that equation for x is going to give me x equals 4, which is my x-intercept. Now I can repeat for my y-intercept by setting x equal to 0. So that gives me 2 times 0 plus 4y minus 8 equals 0. 4y minus 8 equals 0 because my first term is eliminated. And then I'm solving that equation for y, which gives me y equals 2. And finally, I need to rearrange it into slope y-intercept form to be able to identify the slope. So moving everything over to the right and then dividing everything by 4 gives me y equals minus 1/2 x plus 2. I reduced the fraction here. So now I can identify my slope as m equals minus 1/2. Okay. My last example is already in slope y-intercept form, so I can identify my slope right away, and I can identify my y-intercept. In order to find my x-intercept, I can follow the same method I did before and set y equal to 0. That means that I have an equation that looks like this. I'm going to move the minus 5x over, leave the 4 alone, and then divide by minus 5 to give me an x-intercept of minus 4 over 5. Okay. Example 4, now we're going to state the x and the y-intercepts. So remember, for the x-intercept, we're going to set y equal to 0. So in this case, gives us 5x plus 10 equals 0. 5x equals minus 10, which gives me an x-intercept of minus 2. I abbreviated our steps a little bit just by not writing the y term because I know that gets eliminated. The y-intercept, I'm setting x equal to 0, so I'm not going to write the x term. That just leaves me with 2y plus 10 equals 0. Solving that for y is going to give me y equals minus 5. The last example that we're going to do is graph some lines. So you'll notice that the first two are in slope y-intercept form, and the second two are, well, standard form and then something in between standard form and slope y-intercept form. So if you remember, when we are graphing using slope y-intercept form, we're going to identify our slope. We're going to identify our y-intercept. This is our starting point. And our slope tells us our rise and our run, or how we get to the next point. So I'm going to put on my starting point at minus 5. To get to my next point, I'm going to rise 2 and run 1. Now that I've got 2 points, I can connect the dots and draw my line all the way across the graph, and then I label it as y equals 2x minus 5. Let's do the next one. So here my slope is the number in front of the x. Note that I have a negative rise this time. And my y-intercept is minus 2, which is my starting point. So I'll put that point on here, -2. My rise is negative, so I'm going to go down 4 and over 3. And then I can connect those dots all the way across my graph, arrows on the end, and then I can label my equation, x minus 2. Now the next two, one thing that we could do is rearrange them into slope y-intercept form. That works. However, I know that I only need 2 points, and I also know that I can find the x-intercept and the y-intercept really easily from this equation. So what I can do here is if I'm setting x equal to 0, I know that I'm left over with 2y minus 6 equals 0, which gives me the point 0, 3. I can plot that on the graph. That is a point on my line. Now my x-intercept, I'm going to set y equal to 0 like we practiced above. That's going to leave me with 3x minus 6 equals 0, which gives me an x-intercept of 2. I can also plot that on the graph. I have 2 points on my line, so I can then connect the dots here. So I've got y, oh, that's not my equation. I now have 3x plus 2y minus 6 equals 0. The last one, I'm also going to use my x and y intercepts. So to do my y-intercept, I'm going to set x equals 0, which leaves me with minus 3y equals 12, which gives me a y-intercept of 0 minus 4. And then my x-intercept, the other point on my line, I'm going to set y equal to 0, which leaves me with 4x equals 12, which gives me an x-intercept of 3. I can plot those 2 points on the graph, and then I can connect the dots. Now again, I could rearrange those into slope y-intercept form, but it is more efficient to be able to use the intercepts if you're in standard form or if you're not in slope y-intercept form.